Cables and connectors for Wi-Fi. This is Paul Stephenson from Solwise. The connectors in Wi-Fi have to be quite low loss because we're talking about 2.4 to 5 gig. So connectors and cables all have to be specially designed for that. A couple of cables that we handle are this one, which is LMR 200 or HDF 200 in the version we sell it. It's a low loss version of something about the size of RG58 if you're familiar with the old Ethernet standard. It's got a foil screen along with a braid and a solid copper inner. You can see the size of it. It's about 5mm outside diameter, and the loss on this one would be about half a dB per meter. If you want something a bit lower loss, which for longer runs, you'd probably use something like HDF 400, which is this one. It's quite difficult to bend any tighter than a radius of perhaps 4 inches. Solid aluminium inner, which was coated in copper, so you can solder it if you need to. It consists of a PTFE insulator, a wire braid, and an aluminium foil screen. This one's about 0.2 dB per meter loss at 2.4 gig, a bit more at 5 gig. There is a bigger version of those cables which is called HDF 600, but we don't stock it because it's just too heavy, and the tools required to fit the connectors are large bench mounted tools, so they're not practical to use in the field. The next size down on the cable is this one, which is RG316. It's a thinner cable. It's about 3mm diameter. As you can see, it's a copper braid. We don't fit any connectors to this type of cable, but it's available on some of our patch leads. The next one down is this one, which is just called 1.13, which actually describes the diameter of the cable. It's a pretty thin cable, as you can see, and 1.13mm. Loss of about 1.1 dB per meter. Tends to be used for internal, inside laptops, inside any sort of box, not used for outdoor use at all. Right, the connectors that you use on these. Start with the largest one. This one is an N connector. You can see it's about 20mm diameter, something like that, with a pin in the middle. In principle, you can get a reverse version of this. By reverse, we're talking about instead of having a pin in the middle, you have some sort of receptacle, so it's a female. That would make it a reverse N connector. In terms of how we name these things, a plug is generally regarded as something that goes on the end of a piece of wire, like this, and we say that a plug always has a thread on the inside. That tends to be a clearer way of describing these things. So a normal plug would have the thread on the inside and the pin on the inside on the plug, so that would be a standard plug. If that pin was reversed to make it into a female point, it would be called a reverse N connector. Similarly, a socket is always a device with the thread on the outside. So this, for instance, is an N-type socket. In this case, it's an N-type chassis socket, which means we've got this nut on it, meaning it will mount through a chassis. We tend to stock mostly chassis sockets on our pigtails because then you can use it either as a lines connector or a chassis connector. Okay, the next connector down is a TNC. This is a TNC connector, and again you'll see a pin on the inside of this one, which is a socket. So when there's a pin on a socket, it's called a reverse. So this is a reverse TNC socket because it has thread on the outside. Let's have a look at this one. This is a reverse SMA connector. It's a plug, which means that the thread is on the inside, but inside there isn't a pin. It's a female receptacle in this one. So that makes this a reverse SMA connector. This one is thread on the outside. As a result, it's called a socket. It's got a pin on the inside. Because it's a socket, that makes it a reverse SMA socket. Next connector down would be probably a lucent. A lucent, sometimes called an MC connector. This is actually a right-angled lucent connector. Notice that the pin is on the inside. It's a standard plug. I haven't seen a reverse Lucent. Possibly they exist. And it's got this characteristic shell on the outside which makes the ground connection. It's quite a difficult one to focus on. There are probably some nice clean photographs on our website. You can get a feel for the size of it anyway. Another one about the same size is one called an MMCX connector. The MMCX connector is again about the same size as a Lucent. Pin on the inside usually. No threads on these. They just push in. They can be sometimes rather difficult to remove as a result. They will often damage the board when you remove them, but that's how they're done, so that's what we have to support. This one's on a 316 cable that we talked about. And then we get to the smaller one still. This connector is called a IPAX or a UFL connector. You can see how tiny this is. Let me see if I can get that in focus. That is a very small connector. They tend to be fitted onto mini PCI cards that go inside laptops, and also for the outdoor wireless are quite often fitted like that. One more connector, which is a new one to us. It's called a Huawei connector. It's the one used for 3G, and we're starting to do quite a quantity of 3G. So this is the device that you'll find on the modem that you can get with a 3G service. Tends to be connected to something like an SMA on the other end on these pigtails. That's about it for now. More information on the website.